I believe I can fly. I believe I can touch the sky.
A cat who weighs 10 kilograms jumps out of a plane because he feels like skydiving. How long does it take the cat to get within 0.001 meters per second of terminal velocity? As you can tell, the cat is jumping out of the plane, lands safely off of a trampoline. And there's drag force pulling it up, and weight pulling it down.
So in this problem, we're trying to find the time to reach the terminal velocity of the cat falling. To do it, we're just going to start with the equation force equals mass times acceleration, which I'm just going to say F equals ma. Alright, and for the time, we're just going to solve for when a equals 0, and that is because acceleration is the derivative of velocity, so dv dt equals a.
So I'm going to write down a few helpful equations that we're going to use. Because we want drag force to equal weight, that's going to mean that acceleration equals 0. We're going to need to know what weight is. Weight is the same thing as mass times the gravitational acceleration. Let's just say g. Now g is the same, g equals 9.81 meters per second squared. So the mass is going to be 10 kilograms. Now we also need to know the equation for the drag force, because we need to have these equations balanced out. So we have the drag force, let's just say D, equals 1/2 c rho area times velocity squared. So the c is the drag coefficient. And then in this problem, it is very, very close to 0.6, because that's what it mostly like at the temperature that people die from. So the rho in this problem is going to be the density of the fluid, which is air. And that is going to be 1.204 kilograms per meters cubed. The area, we're saying that the cat has an area of 0.4 meters squared. So that's just going to be area. And the v in this is just velocity. That's what we're trying to find for, so we can find the terminal velocity. So because we want these two forces to cancel out, we'll have weight minus drag force equals 0. Therefore, weight will have to equal the drag force. So we can set it all up. We can have mass times gravitational acceleration equals 1/2 c rho a v squared. So we can substitute everything in. 10 times 9.81 equals 1/2 times 0.6 times 1.204 times 0.4 v squared. So once you solve for all of this, we're going to have that v squared equals 678.98671. Take the square root of both sides. We have that the velocity, the terminal velocity for this problem is going to equal 26.05737 meters per second. But the problem is, we want to find when it reaches 0.001 meters per second within that, because it will take an infinite amount of time to reach physically that number. So we'll just subtract 0.001. So we have 26.05637. And that's going to be our endpoint for our integral.
So now that we found the terminal velocity, we still want to solve for how long it takes to get there. But before we do that, let's look at this. What is the force actually? The force is drag force and weight. Weight is the weight of the gravity is pulling the cat down, and we're going to call that weight. And air resistance is pushing the cat up. We're going to call that drag force. So which one's stronger? Weight is stronger. So we're going to have F, that's the total force, equals mg, that's the stronger one, mg minus the weaker one to, we're just going to call this D since we already found it. And what is F? F equals MA, so we're just going to put in MA for that. G minus D, so we can make that D. And just going to divide everything by M, make it easier, because we want to know when this is 0. So it's going to have A equals G, it's an A, minus D over M. What is A again? A is dV dt, derivative of velocity equals acceleration. So we're just going to sub that in. So dV dt equals G minus D M. I'm going to put this thing back in here. So make it dV dt equals, I'm going to also put 9.81 for this, because we're going to do actual math now. Minus. I'm just going to erase this. So we have this, and we already know what this number is right here, so we're just going to do dV dt equals So we got the equation dV dt equals 9.81 minus that. What we're gonna do is we want to take the integral of this, so we're gonna move the dt here to this side of the equation, and we're gonna move this whole thing over here under the dv, because we want the v's to be together, dv and v squared. So it's gonna be dv over okay, now that we have that, we're just going to take the integral of it. And here's the bounds are going to be 0 to t. Okay, and here the bounds are going to be 0 to 0.01 away from the terminal velocity. And that's what it is right here. So we're just going to put that there. Basically, we just put this in the calculator to save up some time. This is going to be t equals 14.42. This is the time it takes the cat to reach 0.001 away from the terminal velocity. And it's pretty much going to stay like this the entire time until it hits a trampoline and bounces off.
I think about it every night and day. Spread my wings and fly.